Of all the dimensions known to man, there is only one in existence that you can enter, where three-dimensional printing meets the bone zone.
Ultimaker CURA is a free slicing software that is pretty popular and very useful for 3D printing. It is the main slicer I personally use, and so I'll be walking through CURA. All of my more advanced settings will be detailed in another video. CURA is quite powerful and friendly to use, and hope this can guide you through the slicing process. The slicing software is quite an important tool for 3D printing, as it transitions the complete model into the G-code that the printing machine understands. There are many settings that can affect quality, both improving or diminishing aspects of a print. To download CURA, a quick Google search for Ultimaker CURA will show the ultimaker.com/software for the official CURA software download. Also, there is quite a bit of information on this Ultimaker website, so feel free to read through if you want to know more details. Otherwise, the download button should be right there to click and then choose the one needed for your operating system. I have Windows myself. It shouldn't take too long to download. I also have older versions installed, so I just installed the newest version at the moment of 5.0. When it's done, find and run the .exe to start the quick install. In my download folder, I click to run, maybe having to run as an administrator. Click accept changes if that window pops up. Starting the install, click the next button, then scroll and agree to the terms, and then select the destination where you want CURA to be located. Name the start menu if you want to. Click install and sit back and wait. Maybe call your mom while CURA installs. Anyway, with the installation complete, click finish, which will then prompt to run CURA 5.0 now if this box is ticked. With CURA open, it's time to get into the fun stuff. It seems my old settings have been saved and applied to the new version, so I will go through some of the beginner steps from a previous recording of version 4.10. First, you should be greeted with a welcome message. Click get started and then agree to the user agreement and continue with clicking next. Signing in is optional, so I'm going to skip it for now. Setting up the first printer is important, as these have certain default settings. Add a non-networked printer, which pulls up a bunch of default options to choose from. Since mine is a Creality Ender 3 V2, I scroll to Creality 3D and select the regular Creality Ender 3 option and give it a new name. The Creality Ender 3 option gives these default settings of 235mm for X and Y lengths of the heated bed size, and 250mm for the Z height for the total build area. The defaults are fine, with the default G-code being Marlin. It also shows the printhead defaults with a bunch of offset values. Leave these default as well. There is also the start and end G-code, leaving these unchanged too. The extruder tab shows the nozzle settings being 1.75mm compatible filament, and everything else is blank. Click next through the rest of the notes to finish and finally use CURA. This home view shows the build plate area where models will show up that are to be sliced. Again, referring to an older recording, the more complex slicing settings are this right tab, which is default to standard quality with these few options. These show the layer height from 0.08mm to 0.32mm, infill from 0% to 100% in 20% increments, a checkbox for gradual infill, a checkbox for support material, and a checkbox for adhesion. I use custom settings and will go through all the basic ones. First, I want to get rid of the annoying blind white theme, and will show how to get the dark theme. In the top left, click on Preferences and Configure CURA. Click on the General tab, and the theme option is at the top here. Change it to Ultimaker Dark. I also changed the currency to US dollars. Now close and reopen CURA for the changes to take effect. This looks great. To start, use your mouse to move around. Right-clicking can pan around the build area, and by clicking the middle mouse, you can move around horizontally and vertically. You can also press Shift and right-click for horizontal or vertical movement. Scroll with the mouse wheel to zoom in or out of view. Near the top of the left tab shows the printer selected, and middle tab shows the kind of filament with the nozzle size, default being PLA material and 0.4mm. Now going through the custom, this shows some basic settings for the quality, the walls, the top and bottom, the infill, the material, the speed, the travel, the cooling, the support, and the build plate adhesion. The other tabs have other settings that I don't use for normal prints, they are especially custom. At my experience level, I currently use quite a lot of other settings, but that is for a future video, as I mess with many that can be fine-tuned depending on the print. With these basic settings, I will show the process of a basic slice, how to add a model to the build area, and what the slicer does exactly. Clicking the folder top left will bring up your file explorer. I navigate to my computer folder with my model files or STL files. You can also right click the folder, showing some other options. I will select to add this model, and then click slice near the bottom right. Zoom in to get a better look at the smaller model of a Charmander. After slicing, 2 more options of preview or save to disk come up. I will preview this before saving. The preview shows how this model is sliced. Then you can save this sliced model. This will save the G-code, which is the code the machine runs to print this model here. I'll move on to some more CURA basics before circling back to explain more details about slicing. The top bar has more options in File for project options, Edit for manipulating the models, View for some camera settings, Settings to add or change printer or different extruder nozzles, Extensions for extra miscellaneous, Preferences to configure CURA, and Help for, well, help. To preview all the CURA settings, select Settings and configure setting visibility. This will show the long list of settings. There are a lot of settings to go through. For now, just the basics will do. There are the tabs on the left side for general, slicer settings, printers, materials, and profiles. Feel free to look through some of these to get used to the tabs. Hopefully, you're a little more comfortable with CURA, so now to get more in depth with the process. To upload a file of a model, we'll need a model first. There are a ton of websites that provide free models to download and print. I usually use a website called Thingiverse, but be sure to look as there are other several websites for model files, as also be wary as Thingiverse recently has gone down in quality, but will work for finding some nice models. Prusa has also recently announced their own model sharing website through printables.com, which may be another great place to check out. At Thingiverse, it shows the homepage filled with recommended models for printing. Weirdly enough, most of this page directed me to a 404 error. So I will search for a model I know works to showcase, and a nice list of first prints to try is extrusion covers, tool holder, dampening feet, or even something like a phone stand. I search for the tool holder, which returns many search results, and looking through this one looks great, and should hold all the given tools for the printer, so click on the thing. Scrolling down shows the details of the make, the files for download, comments from others, makes of this thing, remixes of this thing, and apps. It's always good to look through the details for information, and maybe something is necessary that the maker is trying to inform you of. This one seems pretty straightforward. Click the files to download the model. There is the STL file that I choose to download. The slicer has many options for supporting model file types, but I usually stick to STL files. I have a folder full of STL files, so I drag this new download there. With the file downloaded, it's time to throw it into CURA. I will link all the working Thingiverse files I recommend down in the description. With CURA open, click that open folder icon to choose from your local files and find those STL files. Mine is named toolholder ender 3 v3. Open that file and the model should pop up into the build area in CURA. Moving the camera around shows the 360 view, and underneath the bottom shows a portion of the model highlighted in cyan. This means the highlighted part touches the build plate, so this visually shows the first layer to be printed. Make sure this is a large and flat area for better adhesion. Click the top right tab to open up the settings. First, I change 2 settings for my liking. Under infill options, I lower the infill density from 20% to 8% and the infill pattern to cubic subdivision for slightly faster prints. Under material options, I raise the printing temperature to 205°C and build plate temperature from 50°C to 60°C for better adhesion. You can save these basic preferences by clicking on the profile at the top and selecting Create Profile from current settings. I name my profiles after the layer size, so of standard, and include the nozzle and bed temperatures. Now click Slice, and after a few seconds, it should have 2 options of Preview or Save to Disk. In the preview of the sliced model, it is showing all red and yellow with some green. There is also the view type in the top left bar. I leave mine on Layer View. These are all the different lines, and you can see the line options yourself by clicking the color scheme in the middle bar. For the color scheme, mine is set to line type, showing all the lines for the extruder, helpers, shell, infill, start points, top and bottom, and the inner walls. I also check off the travel to see the travel movements. Off to the right shows all the layers which can be moved down to start at layer 1. I uncheck the travels for now. Layer 1 shows the bottom layer in yellow, with the green lines being an inner wall, red being the shell or outer walls, and the white dots are for the starting points. The outside helping skirt shows as cyan. Going up in layers starts to show the infill for the model shown in orange. This helps me clearly see all the printing lines. Now looking at the model, there is a part that seems to be floating in the air. This is not good as the printer cannot print on air as a print adhering to the bed or the previous print lines. This other angled part seems to be fine as it is slowly going outwards, not printing over the air. To see the problem, click play near the bottom here to see this whole layer play out. To now fix this problem, supports are going to be needed. So under support options, I select to turn on supports for this model, which supports these hard or impossible areas to print. I also selected touching the build plate for support placement as to avoid supports on the inside or on top of the part. Only these hanging parts over the bed surface will be supported. I slice the model again since the settings changed. Now at layer 1, there is more cyan or helper lines showing the support lines that will print underneath the floating bit of the model. Going up the layers shows the support going up and just about touching or supporting the floating bits. This gives the plastic a place to print on instead of over air as shown by the darker blue lines. Now the model is supported and should be ready to print. I'll watch this play out again to showcase that now the model will print over the support structure as I want it to. The default support overhang angle is 45 degrees, but changing that puts more supports at a lower angle or less supports at a higher angle. Changing this setting to something like 80 degrees clearly shows a differentiation from only 45. There is much less support structure. The floating part is not nearly as supported as with 45, but might just be enough to print out fine. 60 degrees should work just fine, so with all these settings and the model slice for a good sturdy print, save the file. I have come up with my own naming scheme for printing files, so try out your own. Now you have saved the G-code file, the file with the code or instructions that the printer will run off of. Plug in the mini SD to USB drive so you can access the mini SD card files, and save the G-code there or drag it from your local file. Make sure the file is saved in the right drive. To summarize, I'm going to go through slicing another couple models, which first is a calibration or stress test that I found online. Click New Project to clear the build area and adjust the view back. Take note this left corner with the 3-axis line relates to the bottom left corner of the printing bed, or the starting point of 0x, 0y, and 0z. On Thingiverse, I looked up all-in-one test and chose to print this one. You can also click through the photos to find the blue model and click the cube to rotate the model around on the Thingiverse website. With it downloaded, open the STL file of the model. This model has overhangs, bridging, gap clearance, holes, thin towers, and more to test all kinds of functionalities and capabilities of a printer. This model should be tested without supports on, so turning off that setting and now hitting the slice button. Another beautifully colored model showing all the different lines. By the Save to Disk button, there is more information showing this print will use about 39 grams of filament or material. It guesstimates the print time to be about 6 hours and 15 minutes with our current basic settings. Hovering over the eye bubble icon shows the time breakdown for the infill, inner and outer walls, retractions, skin, skirt, and travel time. Save this model to the SD card to test how well your machine will handle these conditions. Another test model to print first is the classic boat, called the 3D Benchy. It seems the original Benchy has been removed from Thingiverse, but I found this one that should work just fine. This picture shows that it has some circular parts, small overhangs, curved parts, straight parts, tiny circles, and more. The whole shebang in a cute little boat. Remember to check the files you're downloading and make sure to select the whole model file. Again, with a new project, select the STL file and the boat comes to life. This is a really good base print to have with default or very basic settings, so you know what your first print looks like before messing with a bunch of crazy complicated looking settings or doing any modifications to the printer itself. You can left click the model to move it around. I have found it sometimes easier placing it closer to the edges to help avoid a warped bed. You can also resize the models to almost any size by clicking on the left side panel or just pressing the S key. I keep mine at 100% size. To rotate the model, press the R key, and I keep mine as is. Press the T key to go back to movement. CURA will show anytime the model is placed incorrectly, so it has safety cautions to prevent bad G-code. Click Slice, and again taking another quick look at the Slice Benchy model shows some of these small details. Taking a closer look at the layers shows all the lines that the nozzle takes to print that layer. The tiny hole, some of the curves, the bigger hole, and then even at this layer, the boat is printing a small bridge over this top part. Since this is small and connected to the print, this should not fail and can show how well the printer can handle a small bridge. One last test model to print first is the XYZ Calibration Cube. This cube should be around 20mm on all sides and can be measured to show size accuracy. With all these test prints, I hope this video introduced you to the basics around Ultimate CURA, so look out for a much more detailed video of all my personal settings if you want to know more. Thank you so much for watching, now go slice the world into G-code.